A function is a relation between two or more variables in which the inputs are used to determine the unique output. Typically, f of x notation is used to describe a function. This notation describes x as the input and f of x as the output. For example, if f of x is defined as the expression x squared minus 3, then the input is x and the output is x squared minus 3. The output of the function is determined by squaring the input and then subtracting 3. We can help identify the function by creating a table of values. The x value is the input to the function, and the y value, f of x, is the output. When x is negative 2, y equals f of negative 2, which equals the negative 2 squared minus 3, which equals 1. When x equals negative 1, y will equal to negative 2. When x equals 0, y will equal to negative 3. When x equals 1, y will equal to negative 2. And when x equals 2, y will equal to 1. Plotting these points on a coordinate plane will give us the graph of the function. Notice that the graph gives the complete picture, while the table of values gives us just specific points on the graph. Here is an example of the use of a function. An oil pipeline has developed a leak and is leaking oil that produces a circular oil spill that is increasing in diameter at a rate of 3 centimeters per minute. If the oil spill currently has a radius of 2 meters, determine the function that gives the area of the oil spill t minutes from now. Then use the function to determine the size of the oil spill 60 minutes from now. Essentially, we need to find the area of a circle. The formula for the area of a circle is A equals pi times r squared. The current area is pi times 2 meters squared, which is pi times 4 meters to the second power. The value for pi is approximately 3.14. 3.14 times 4 is 12.56. The current area of the circle is approximately 12.56 meters squared. We will use the same area formula to find the area function for the oil spill t minutes from now. The diameter of the oil spill is growing at a rate of 3 centimeters per minute. In t minutes, the diameter will be 3 centimeters per minute times t minutes, or 3t centimeters. Since the radius is currently measured in meters, let's convert from centimeters to meters. There are 100 centimeters in 1 meter. To convert 3t centimeters to meters, multiply by 1 meter divided by 100 centimeters. The diameter of the circle t minutes from now is 0.03t meters. The area formula uses the radius, which is half the diameter. 0.03t divided by 2 is 0.015 t meters. The change of radius is 0.015 t meters. The function that describes the area of the circle t minutes from now can be written in the function form as a of t. If a equals to pi times r squared, where r is the current radius, which is 2 meters, plus the change of radius, 0.015 t meters. This will have our area formula as pi times 2 plus 0.015 t squared. Again, this can be written in the function form as a of t. After 60 minutes, the area of the oil spill can be calculated as a of 60, which equals to pi times 2 plus 0.015 times 60 squared. 2 plus 0.015 times 60 squared equals 8.41. 8.41 pi is approximately 8.41 times 3.14, which equals to 26.41. After 60 minutes, the area is approximately 26.41 meters squared. You should look over the examples on the web page and then test your knowledge using Test Yourself.